DMF section 3.2.S.7 Stability. The DMF in CTD format consists of 7 sections. In this video, we will talk about the last of them all, section 3.2.S.7, which is about the API stability. Our aim here is to know for how long the API can be stored in the temperature and humidity conditions it will be exposed to, using the packaging material that was described in the previous section, considering the climate of the country where it is manufactured, as well as the country where it will be used in the drug product formulation. There are different climate zones in the world, and the most critical condition must be considered for the stability studies. For example, if an API is produced in China, where the climate zone is Zone 2, but shipped to Brazil, where the zone is 4B, the stability study must consider Zone 4B, since it is hotter and more humid. Alternative conditions may be used in case of a controlled transport chain. Now, there are various studies that must be performed to understand the API stability. The first one is the force degradation study, which may be presented here or as part of the analytical validations in section 3.2.S.4.3. One of the objectives of this study is to expose the API to stressing conditions so that in a short period of time it is possible to identify which conditions lead to degradation of the API and, as a result, which conditions we want to avoid during its life cycle. This study includes, for example, exposure to light, heat, humidity, oxidation, and acidic and alkaline hydrolytic conditions. In order to identify if an API is sensitive to light, the ICH Q1B guideline must be followed, which recommends a confirmatory testing for photostability, in which the API must be exposed to at least 1.2 million lux-hour and 200 watt-hour UV light. This study allows us to conclude whether the API is considered photosensitive or not. Another study is the accelerated stability study, in which the stability of the API will be evaluated for 6 months in conditions a bit more extreme than the normal ones, and the long-term stability study, which must represent the actual conditions to which the API will be exposed throughout its shelf life. The conditions in such studies depend on the climate zone. For example, for Zone 4B, the accelerated stability is done at 40 degrees Celsius and 75% relative humidity, while the long-term stability is done at 30 degrees Celsius and 75% relative humidity. The packaging material where the API is stored during these studies must represent the commercial packaging, which was described in section 3.2.S.6. In these 2 studies, the API stored in these conditions is tested throughout the time to understand if it is still approved in the quality control specifications. Here, it is not necessary to perform all the tests that are done to release the API, only those which may be impacted by the API degradation. Besides, we need to be sure that the assay and impurities methods that are used in these studies are in fact considered stability indicating. And here comes the second objective of the force degradation study, demonstrating that this combination of methods for assay and impurities is capable of specifically separating and quantifying the API and all the expected degradation impurities. This means that if the API degrades and there is an increase in formation of impurities, this behavior must be shown by such methods. So we should not have co-elution of the API with impurities, which would hide this degradation. Therefore, a good resolution between peaks must be shown, as well as the peak purity for the chromatograms. Hence, our intention in a force degradation study is to see formation of impurities, so that this can be evaluated, but not in an exaggerated way. We usually look for up to 10% degradation to avoid secondary degradation products, which would not be expected in the real life of the API. Moreover, ICH Q1B also recommends a photolytic force degradation, which in general is a more extreme condition than the confirmatory test, since its objective is to form impurities to demonstrate that the method is stability indicating. A common deficiency is that there is no degradation in the first degradation study because the API was not stressed enough. For example, the API was exposed to heat for only 1 day, and a conclusion was drawn that the API was stable to heat. The recommendation to seek the formation of impurities in this case would be to continue the exposure for up to 7 or 10 days, so that the study can finally be ended in case there is really no degradation. If the first degradation study is okay, demonstrating that the methods are indeed stability indicating, the long-term study associated with the accelerated one will allow the manufacturer to establish an expiry or retest date for the API. For example, if after 36 months the API does not pass in one of the tests and the last time with approved results was 24 months, then the expiry period will be 24 months. These conclusions are presented in the first part of the stability section, which consists of the stability summary and conclusions. After that, post-approval stability protocol and stability commitment are presented. This is a study done after approval of the API, adding 1 batch per year in a long-term study. Finally, the stability data subsection will be where all the results are presented for the studies we have discussed: the photostability study, the force degradation study, the accelerated and long-term stability studies, even if they are still in progress. And this was the stability section, which provides so much important information about the conditions where the API must be stored and for how long. And this is how we end our series of videos about the different DMF sections. Thank you for watching and see you next time.